If you have a lot of parts that you need to lap, and they're the same curve, I mean you have a lot to do, it makes sense to use a diamond pellet lap. Not something amateurs usually do. But here I've got a lens that I'm making, and it's one of my solar projector lenses, and I had a lot of those to do. And what I used to make it was a pellet lap. And basically it's a, well, this is a glass lap, usually made out of metal, but I took a pellet, and these are diamond pellets that are, these were 10 millimeter sintered bronze or copper with 10 micron diamonds in them. And I took a chisel and cut them into quarters, and then I glued them onto this lap. And then it's kind of a tedious process to get them worked in and running well, because the lap you put them on has to be the right offset curve to the lap you're working, and there's a learning process on how to do that. These are glued down with epoxy, and this lap is 85% as large as the lens I'm working, and that's been worked in, but it takes a little time to get used to doing that. But I've already done that on this lap, and they also take a lot of force. I've got a bunch of weights stacked up on here because each pellet requires a certain amount of force. And see my stack of weights on here. I'm not even sure that's enough yet, but you have to be careful that you don't put too many pellets on, because then it needs a huge amount of force. So I'm going to run this and put water on. Actually, you can probably be better to use a water-soluble oil, but I don't need to run that many parts. And these laps, these diamond laps, can take a generated surface, say a 120 diamond generated surface, and bring it up to a polishable surface in a matter of minutes, typically maybe 5 minutes, running it like this. And they can last for thousands of parts. So these are usually done in production. Again, not something ATMs usually do. And you need a little bit of a stroke, because you have to randomize the distribution of the pellets. Oh, that wasn't very long. But also notice that the pellets on here are kind of randomly distributed. You be careful that you don't have to, you don't have one right in dead center. That's never good. But basically that's how this works. I'm going to run this part using diamond pellets. Okay, so here's my finished lens. Didn't think to time it, but it's certainly well under 10 minutes it took me to run it. So that's, pellet laps are really great because they really are fast. But they do have their own problems. You can't keep running a part. pellet laps require that you start out with a rough generated surface, because as that rough surface starts coming off, it erodes the matrix that the diamonds are in, and that brings new diamonds to the surface. So if you keep running the same part over and over, it will actually, the diamonds will wear down and it'll start polishing up and start scratching. Another thing that can happen with pellet laps is you'll get especially with bad quality pellets, you'll get a rough diamond that's too coarse, and it'll start scratching your part. And but you can usually see them on the pellet because it looks like a little star, because the matrix is fresh that's eroding around it. Kind of looks like a little comet or a star. But they're pellet laps are really neat because they're fast, and that's why they're used in production. Okay, to polish my lens, I'm going to use LP66, and what I've done so far, I took my my porcelain discs that I made out of tile, and then I ground my lens against it and to the right radius that I need, and then I took some contact cement and glued this LP66 to it, and that's just this is 20 thousandths thick polyurethane foam. Has a lot of holes in it, and this radius is pretty flat, so it should be offset by 20 thousandths. But on this longer radius, it doesn't matter. So then I put it on contact, and then rubbed it down good with a piece of Teflon. Then I'm going to trim this back. Okay, the next thing I did, trimmed off the edge after this is dried, and fairly dry. And then I made a little template. I want to feather the edges, and I want to feather the center. Feather edges because the part is smaller than the lap, so with a normal stroke it's going to want to go steeper, so I want to try to inhibit it from going too steep. And also I'm going to put a little flower in the center. Anyway, I made a little mask out of template out of plastic, traced that on ink, and then I'm going to cut in between with a razor blade, yeah, along the lines, and then just peel that off like so. Then I'm going to go around and do all these like that. So on and so forth. So here's my almost finished lap. I put a little star in the center, and that's for when the stroke gets short. When I want to make it go steeper, if I shorten up the stroke, the area in the center will help it go steeper. I still have to dress the lap, but that'll be next. Okay, to dress my lap, I took my part with the right curve on it, and I put some wet dry sandpaper on it, 600 grit, and I stuck it on with double-sided carpet tape. And now I want to basically sand my lap. A little bit of water, and I could have just ran the part, not breaking it in, and it would still work, but it would take a while to work in well. This will just speed things up a bit. And if I want to change if my part comes out with a steeper or flatter radius than I like, I can use this lap the sandpaper lap to correct the radius a little bit. So I'm going to just run this on kind of a slow speed. Just kind of sand it. Doesn't actually take very much sanding to do it. Just kind of knock the high spots off. Somewhat like that. It's probably enough. And I'm going to rinse it off well in the sink so I don't get any sandpaper particles on my part. So now I'm ready to run a good part. I put packing tape on the back of it to protect it. And I put a button on with double-sided 3M tape on it. So run about, oh, what's that? 3, 6, 8.5 pounds of weight on there. And I'm going to run it. The stroke about like that. And if I want it to go steeper, I'll push it closer to the center, the offset. And if I wanted it to go flatter, I'll push it farther out. But I think that right there is about a kind of a neutral stroke. Okay, so after 30 minutes polishing, my part is almost fully polished. There's just a few scattered pits here and there. And actually, with good technique, you can polish these parts in 30 minutes, easy. Heck, LP66 is a very fast polishing pad. When I used to work at US Precision Lens, we had big heavy machines that had a lot of pressure and speed, and they were polishing parts this size in 20 seconds. But they weren't, they also weren't telescope optics. But I'm going to run this part another 30 minutes. You know, another way you can use LP66 as a polishing pad on your pitch lap. You can take your pitch lap and make it tacky with a rag and some acetone, and then lay a sheet of LP66 over it and press it in, and it makes a very fast polishing. And then when you're done, you can just peel it right off and you can reuse it and go directly forward with pitch. And there's another lap I got here for doing planos. It's an 8-inch lap. So LP66 is a pretty neat polishing pad.
Headed down south to the land of the pines, thumbing my way into North Carolina, stirring up the